Okay, the first thing we want to find out about this circuit is how much power is generated by the source. In order to do that, we need the current. So I'm going to define a current direction, I sub s, and then power will be equal to the 30 volts times whatever I sub s is by definition. The easiest way to do that is going to be to probably reduce this entire circuit, find an equivalent resistance, and then divide the source, 30 volts, by that equivalent resistance. So start looking for parallel and series combinations of elements. These two are in parallel, so their equivalent resistance is going to be the product of the two, 3 ohms times 6 ohms over 3 ohms plus 6 ohms, which is going to be 2 ohms. Now I'm going to redraw the circuit with that in place and look for more parallel and series combinations. Now these two are fairly obviously in series, so adding them together, that becomes an equivalent 3 ohm resistance. Now this 3 ohm and that's 3 ohm resistance are in parallel. That'll result in the same equivalent resistance as this combination up here, so this becomes 2 ohms. My next circuit becomes, these two 2 ohm resistors are in series, that becomes 4 ohms. That 4 ohms is fairly obviously in parallel with that 4 ohms, so the equivalent resistance, Req, is 4 times 4 over 4 plus 4, the product of the two, divided by the sum of the two, ohms, which is 2 ohms. So I sub s is going to be 30 volts over 2 ohms, or 15 amps. And the power delivered by the source is going to be 30 volts times 15 amps, which is 450 watts. Now legitimately, one of these should have a minus sign in front of it since current is entering the negative voltage terminal. So negative 450 would also be a good solution. It does ask for the power generated, so I think you could argue that you could give a positive number for that if you wanted to. Now let's take a look at the current through the 1 ohm resistor. We want this current here, I1. Let's look through our other circuits and see where else we can find that value. That corresponds to this current here, I1. Those are in series, so they share the same current, so that's also this current, I1. Now the next thing that I combined over here, I lose that current. However, let me define a voltage across here, say V sub x. So V sub x is going to be 3 ohms times I1. V sub x does show up on this circuit down here. Now in this circuit, I know that I have 30 volts across a series combination of two 2 ohm resistors. Let me make myself some more room to work over here. So from this circuit here, I have 30 volts, 4 ohms, 2 ohms, and 2 ohms, where this is V sub x. It's the voltage across this parallel combination of these two resistors, and I know that this voltage between here and here is 30 volts, so V sub x is equal to 30 volts times 2 ohms over 2 ohms plus 2 ohms, my voltage divider formula. So V sub x is equal to 15 volts. Now I1 from this equation is that voltage, V sub x, over 3 ohms, so I1 is 15 over 3 amps, which is just 5 amps.